Dream to become the next Sir Isaac Newton or Albert Einstein? Learn from the master. Refath Bari. Watch his videos to achieve your dreams.
Hello, folks.
Hello,
Instructor.
hello,
Instructor.
instructor.
Name is instructor.
Welcome to lecture 20 of linear algebra. Today we're going even more in depth with the dot product, and today is a very important day because we are looking at one of the most special properties of the dot product. So let's get us started with the do now. So the do now should be a kind of review for you. Hopefully it's very easy, but if it's not, that you can watch some of the previous videos. So just go ahead, try to answer these questions as best as you can, and keep in mind that these are all questions that were covered in the previous lectures. So here's 3 fill in the blanks, and here's another 3 more. So the dot product of the difference.
Watching.
Isaac, can we work together?
Yeah.
Thank you. Can you help me?
Yeah. Did you lose your cold because you sound a bit different again?
Yeah, I was taking medication,
Oh.
but thanks for asking.
Okay, so while I go ahead and fill these out, why don't you go ahead and try answering these questions, and good luck.
The
I got
first
the
one
first
is
three.
v dot v is v squared.
Oh,
Alex, I have
perfect.
a plan. You answer the least complicated. I answer the most complicated.
Okay. So any idea what the second one is?
You answered it. You can do it.
Oh, okay.
So,
B.
You're laughing. I can
this
feel
is
your
actually
nose.
the commutative property.
Oh, v w. Okay.
Just switch
Oh,
around the dot
w
product.
v. Okay.
Yeah. And the last one is just a simple example.
Distributive property.
So v dot w plus v dot k. So this
Okay,
very
I'll answer
easy.
the most complicated.
Okay,
Okay.
So,
Go ahead.
v plus w squared, and I know you like to mess around and do the complicated
Good,
stuff.
good.
So,
So, let's
magnitude
do
of
that.
v squared plus v dot w to
Plus-
v
plus
dot
what?
w
plus what?
to v dot w
Good.
plus w squared.
Perfect. What about the second one?
Oh, so the same
I'll
thing
tell you,
except
I'll
it's v
tell you.
minus
Yeah.
w squared. Remember our plan. I'll answer the complicated one.
Okay, so
Okay. What should my longer statement be?
V squared minus 2vw plus w squared.
And of course, this may look easy to you, but to someone new, this may look foreign. And what about our last statement right here?
Oh, v minus w, v plus w?
That was our lecture yesterday, remember?
Yeah, but
So
there's no way to represent it in terms of v and w.
actually, all you have to do is take the difference of the square of the magnitude.
That is one that actually challenged me.
Okay, so hopefully that was pretty easy. Let's move on to a
That
very
was
important.
not easy because I got it wrong.
Yeah. So today's lesson is very important, in part because I'm introducing a very important property of the dot product. So let's investigate what that property is. So, lesson. Okay. So, the main idea today is a concept called orthogonality. But before
That is the professors hate you.
what analytic? What did you say?
Could be in the back of my mind.
Orta.
But before,
Oh, I got it.
Yeah.
Orthogonality.
Good.
Perpendicular lines.
Exactly.
So
But
why doesn't he say perpendicular?
Huh?
Why he doesn't say perpendicular? Why
He
orthogonality?
probably hates us.
no. But I'll formally introduce the definition in a few minutes. But before doing that, let me look at an example. So
So orthogonality means 90 degree.
Yeah.
yeah.
Oh.
So but before we
Two lines
So
that are
why don't you
perpendicular.
just call 90 degree? Why do you call it orthogonality?
it's
can't we
like the
just call it
formal. It's
perpendicular?
like the formal one. Okay.
Perpendicular is formal
Okay.
enough.
Sure. So now let's take a look at an example of what happens when we have two vectors. Okay. So let me give you two vectors, shall I? So I'll write them in blue. So vector V, let's say I'll give you 1, 2. Not bad. And W, vector W, maybe I can make it 6 minus 3. Okay, so before doing anything with these two vectors, it's always a good idea to visualize them. To visualize two vectors, what I can do is draw them out on the coordinate plane. So why don't we draw these two vectors on the coordinate plane? My first vector is 1, 2.
1, 2.
So that's right. I go 1 to the left, 2 up. And my second vector,
6, 3.
1, 2, 3, 4, 5. So 6 would be here, minus 3 is like here, right? So those are my two vectors. But this is vector V, this is vector W, right?
Right.
Now, for the last few lectures, we have been looking at dot products. So why don't we take the dot product of vectors V and W? So
Oh, that's easy.
V dot W.
So it's 1 times 6.
Yeah. Oh, let me write them out. Vector 1, 2 dot vector 6 minus. So what would it be? What would their dot product?
1 times 6.
Yeah. 1 times
And 6 minus 6 is 0.
Plus
plus
It's 0. It's
2
0.
minus
It
3.
is 0.
2
It is 0. It
and
is 0. It's 0.
Oh,
This is
my
6.
God, it's 0.
and this is negative 6, which is a big fat 0.
You
So
don't have to say fat. That's not formal at all.
sorry. So now what you might start thinking is, why is the dot product 0? Is there anything special about these two vectors?
Oh, I got it.
Yes.
Cosine 90 is 0. So it must have
Oh my
something
God,
to do
cosine
with
90 is
cosine.
0, and then it has to do with cosine 90 because this
Maybe,
another
yeah.
formula is the vector
But-
V
Wait,
vector V
wait.
vector.
Calm down.
But
I found
before
something that relates
Okay,
to
yeah.
the dot product and
Um,
cosine.
yeah.
The second definition of dot product.
Good.
Isn't
But-
it V vector V vector V
But before
V,
we-
V times something the cosine theta.
yeah, so
Yeah,
we'll look at that
definitely.
very soon. But before we go to the second definition, just like you guys notice, these two vectors are perpendicular.
What does perpendicular means?
You said it a second ago.
90 degrees.
90 degree.
Yeah. So that gives us a clue as to why these two vectors are special.
I think
Now-
our hippocampus that flew away just now.
Now, let's look at the second definition.
Fly out the window.
Now, let's look at the second definition of the dot product, just as our student here proposed.
So V magnitude of W sine theta.
Oh no, cosine theta.
Why not sine theta? Because I just said sine theta and you decided to write cosine theta.
No, because
No.
that's
We will actually look at the derivation of the second definition of the
We
dot
can
product.
use sine theta as well, right?
No, it's not the
probably
same.
not. Did
Let's
it in
look.
one of my
So-
lectures because I'm a professional professor.
Yeah. So,
You are just
okay.
an amateur at teaching.
Yeah, what is the magnitude of vector V? Can we see?
We don't need.
It's 1 squared plus 2 squared, right?
It's root 5.
Root 5. So this is square root of 5. What about vector W? Can we do the same thing? It's 6 squared plus minus 3 squared, which is thus 36 plus 9. Square root of 45. Square root of 45. But now you'll see I didn't even have to do that. Why? Because notice that the angle between our two vectors is none other than 90 degrees. 90 degrees. So I can write cosine 90.
Which is 0.
Which is 0. And we get the same answer both ways. So now let's look at the general idea. Okay? So the general idea is hopefully very quick. The general idea says that if I have two vectors v,
How did I end up here?
so I will have two vectors v1 and v2 and w1, w2. Now I will ask you this question. Let me just pick up this. So this is the question I'll ask you. If I have two vectors v and w,
Is this an existent?
it is, yes. So if I have two vectors v and w,
Okay.
if v dot w equals 0, then dot dot dot,
W dot B.
no. If they have a dot product of 0, what can we say about two vectors?
Perpendicular.
Correct. Okay, folks, so thank you for watching, and
Oh.
see you next time.
What does this sign mean?
Perpendicular. Oh, should I write it down?
But how do we supposed to know that?
It's
Just
like
memorize it.
V is perpendicular.
Oh no, we're going on an odyssey to teach Alex what
To
perpendicular means.
W. And
And why the perpendicular sign has to be like that?
um,
Why is upside down T? Why not direct T?
unfortunately, I'm not sure.
But it's because
About
the two lines in there are perpendicular.
That's right. So thank you for watching, and we'll see you next time.
Bye.
Thank you.
The Bari Science Lab to fall in love with math and science, especially programs